Hello everyone, welcome to Chandrasekhar Research Academy of Business Studies. In this video, we'll explore large sample tests, focusing on the mean test for the difference between two standard deviations. This concept is crucial for understanding variability between two populations. Let's dive in with a step-by-step explanation. When comparing the standard deviations of two independent populations, the objective is to test whether the difference between the standard deviations is statistically significant. The formula involves comparing the variances, because the variance is the square of the standard deviation. The null hypothesis, denoted as H0, is that the population standard deviations are equal, or mathematically, sigma 1 equals sigma 2. The alternative hypothesis, denoted as Ha, states that the population standard deviations are not equal, or mathematically, sigma 1 is not equal to sigma 2. The Z-statistic is calculated using the following formula. Z equals the absolute value of open parenthesis, S1 squared minus S2 squared close parenthesis whole, divided by the square root of open parenthesis. 2 times sigma 1 to the power of 4 divided by n1 plus 2 times sigma 2 to the power of 4 divided by n2 close parenthesis. Here, S1 squared is the sample variance of the first sample. S2 squared is the sample variance of the second sample. Sigma 1 to the power of 4 represents the fourth power of the population standard deviation for the first population. Sigma 2 to the power of 4 represents the fourth power of the population standard deviation for the second population. N1 is the sample size of the first sample. N2 is the sample size of the second sample. Step-by-step procedure. State the hypotheses. Null hypothesis, H0, sigma 1 equals sigma 2. Alternative hypothesis, Ha, sigma 1 is not equal to sigma 2. Calculate sample variances. Compute the sample variances, S1 squared and S2 squared from the data of the two samples. Compute the Z-statistic. Substitute the sample variances, population variances, and sample sizes into the Z-statistic formula. Compare with the critical value. Use a standard Z table to find the critical value corresponding to your chosen significance level, typically 5%. Draw a conclusion. If the calculated Z statistic is greater than the critical value, reject the null hypothesis. If the calculated Z statistic is less than or equal to the critical value, fail to reject the null hypothesis. Assumptions for the test. The two samples must be independent. Both populations should follow a normal distribution. The sample sizes must be sufficiently large. Example. Calculation. Substituting the values. S1 squared equals 25. S2 squared equals 16. Sigma 1 equals 5. So sigma 1 to the power of 4 equals 5 to the power of 4, which is 625. Sigma 2 equals 4. So sigma 2 to the power of 4 equals 4 to the power of 4, which is 256. N1 equals 50. N2 equals 60. Z equals absolute value of open parenthesis, 25 minus 16 close parenthesis whole, divided by square root of open parenthesis. 2 times 625 divided by 50, plus 2 times 256 divided by 60 close parenthesis. Step 2, simplify and solve. Simplify the numerator, 25 minus 16 equals 9. Now simplify the denominator step by step. Compute 2 times 625 divided by 50. 625 times 2 equals 1250. 1250 divided by 50 equals 25. Compute 2 times 256 divided by 60. 256 times 2 equals 512. 512 divided by 60 equals approximately 8.533. Add the results. 25 plus 8.533 equals 33.533. Take the square root. Square root of 33.533 is approximately 5.792. Now divide the numerator by the denominator. 9 divided by 5.792 equals approximately 1.553. So the Z statistic is approximately 1.553. Step 3. Compare with the critical value and conclude. At a 5% significance level for a two-tailed test, the critical value of Z is approximately 1.96. Since the calculated Z statistic of 1.553 is less than the critical value of 1.96, we fail to reject the null hypothesis. There is no significant evidence to suggest that the standard deviations of the two populations are different. Thank you for watching this video on large sample tests. for the difference between two standard deviations. Don't forget to like, share, and subscribe to Chandrasekhar Research Academy of Business Studies for more insightful content. Let us know in the comments if you have any questions or need clarification. See you in the next video.